Alright guys, here we go. I'm just going to do as many videos as I possibly can explaining how to do all these. I'll go through the whole test that I made. So for number 1, this is actually a question that was on quiz number 3, except for you were solving for delta x. So you can use either one of the uncertainty principle ones. The only one I actually have memorized and that I prefer to use is the delta x times m delta u is greater than or equal to h over 4 pi. So for that, this is going to be our delta x. Our m is going to be the mass of an electron, and h is our constant. So let's go ahead and plug this in. Or let's solve for delta u, which is what we're trying to solve for because of the velocity. So doing some rearranging, I'm going to divide by this, by delta xm, and I'll get delta u is greater than or equal to h over 4 pi over delta x times m. So h, as we know, is 6.626 times 10 to the negative 34. Now you know that a joule is equal to kilograms meters squared over seconds, and h is in joules times seconds. So we have kilograms meters squared over seconds squared times seconds over 4 pi, and that's going to be over the delta x that we're given is 1.7 times 10 to the negative 8 meters. So it's, sorry, my memory is not like super perfect. 1.7 times 10 to the negative 8 meters, and that's going to be times the mass, and the mass of an electron is actually on your potentially useful information, and that is, let me write it over here to the side because we need to turn it into kilograms. It's in grams. Um, 10 to the 3 grams in 1 kilogram. So if you do the math there, you get 9.109 times 10 to the negative 31 kilograms, right? Grams cancels, you're left with kilograms. And then that is going to be less than or equal to our delta U, which is what we're solving for. So just doing the units off to the side, I'll do them over here. We have kilograms meters squared seconds squared times seconds divided by 4 pi, which doesn't have units, and that's over, what do we have, meters times kilograms. So kilograms, seconds, gets rid of one of the seconds, meters, gets rid of one of the seconds. We're left with meters over seconds. And when you do the math, I believe you get delta U is greater than or equal to, I think you get like 3.4 times 10 to the 3 meters per second. So if you go over here, the closest answer is this. You're not going to choose none of the above because you got 3.4 times 10 to the 3. And an answer is 3.5. If you're that close, you definitely just want to choose the one that you're closest to. So the number 1 is A. Number 2. All right. If I go through this too fast, just pause it, go back to it. Okay, so we find out that air consists of 3 major things: nitrogen gas, oxygen gas, and argon. Now, this is important right here. Nitrogen gas, you would think, is just like this, but that's not right. It's N2. It's one of the diatomic elements. Same thing with oxygen. You would think it's just O with a G. Nope. It's O2 with a G. So you're going to use the masses of these when you're trying to figure this out. So now to set this up, you are going to do the molar mass of air equals, sorry, I'm going to do this down here. Molar mass of air equals, you're going to take the percentage of nitrogen times the molar mass of nitrogen, percentage of oxygen times the molar mass of oxygen, percentage of argon times the molar mass of argon. And you're just adding all of these together. So 0.7808 times, I'm going to use rounded numbers. So 14 times 2, that's 28.02 grams per mole, plus, that's just nitrogen twice. That's a really rounded number. 0.2095 times oxygen 16, so 32.00 grams per mole, plus argons, which I believe is like 35. But the percentage I give you is 0.0097 times, bear with me for 1 second, I don't know where, 39.948 grams per mole. When you do the math and add it up, you should get B, 28.97 grams per mole. Now, if you get this answer right here, it's not right because you used half of this and half of this, so you're not going to have the right answer. This number right here comes from just adding them all together, and it's not none of the above. So your answer is B. Okay, so number 3. Determine the magnitude of partial charges in HBr given that the bond length is 1.41 angstrom and the dipole moment is 0.82 dBi. Okay. So if I remember correctly, this is a formula she wanted you guys to know. And the formula goes as follows. Sorry, you can hear a lot of paper shuffling because I'm not very organized. The U equals Q times R. And you're going to solve for Q. So Q equals divided by R, where R is your atomic radius. Q is the magnitude of the charge, I believe. And U is your dipole moment. Okay. So first thing I'm going to do with this is I'm going to take my my R. You can do either one first, but I'm going to do R. My 1.41 angstroms and I'm going to turn that into meters, and you'll see why in 1 second. So 1 angstrom is 10 to the negative 10 meters. So we get 1.41 times 10 to the negative 10 meters. That's our R, and our U is 0.825, and so we want to get this. We're going to find out the partial charges, so we need to put this in something that relates to charge. In this case, you want to turn debye into coulomb meters, because you're going to be dividing by meters. You'll get coulombs, and then you know that 1 electron is 1.6022 times 10 to the negative 19 coulombs. So 1d over, not one direction, one debye, 3.336 times 10 to the negative 30 coulombs meters. And that will give you, I'll write it down here so it's easier to see, 2.74 times 10 to the negative 30 coulomb meters. All right. So, moving on, we know that Q equals that divided by that. And then I'm going to add an extra step. So we're going to be in coulombs. 1 electron, which is the charge, is 1.6022 times 10 to the negative 19 coulombs, right? So plugging everything that we figured out in, Q equals 2.74 times 10 to the negative 30 cm over 1.41 times 10 to the negative 10 meters times 1 electron is 1.6022 times 10 to the negative 19. What happened? Where'd it go? C. So when you do the work, let's cross out our units. Bam, 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 bam. Doing math, you'll get 0.121 E, and we started off with 2 sig figs, and that's the 2 sig figs comes from your debye, so 0.12 would be your answer there. All right, scrolling around all willy-nilly, we get, oh, it's an answer. A, 0.12. All right, 2 sig figs right there, 3 sig figs right there. That's going to determine your sig figs. All right, so I'll post the next video in a second.